morning, students. This is Dr.G. Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, I would like to discuss about mission design topics. So, in the part of mission design, first of all, I want to give some introduction about design. So, in this session, we will see what is mission design and what is the importance of mission design for engineers and what are the general considerations in design of mission elements, and finally we will see general procedure and then problems. First of all, we will see the definition of the mission design. The mission design is defined as the use of scientific principles, technical information and imagination in the description of a mission or a mechanical system. For what purpose? To perform specific functions with maximum economy and efficiency. So it means, so this definition involving some basic features. What are they? That is some basic knowledge of science and some engineering knowledge of science. So the basic and engineering knowledge of science means in the terms of subjects, physics and engineering mechanics and thermodynamics, heat transfer and mechanical vibrations. So like that, the engineering subjects, first of all, he has to learn. So after that, after study of these basic subjects, the student has to apply whatever learned the scientific principles and technical information for new design or to perform a new mission with maximum economy and efficiency. So that is the definition of the mission design. In another way, also we can define the mission design is defined as the creation of new design or improving the exist one. So entirely it may be new or some modifications of an existing one. So it has to show some improvement, so the betterment than the previous one. So that also called as design. So it means the mission design creates a mission, new mission for to perform to perform work effectively and more reliably. So in the definition of design, you can learn, you can apply. So the principles of the engineering mechanics and physics and thermodynamics. So like Boyle's law, Charles' law, and Newton's laws of motion. So like that, the various principles are there. So all these principles apply for our problem and find out the feasible solution. So that is called as the mission design. Next one is the important thing is in the mission design, the general procedure. What is the procedure in mission design? Which procedure you have to follow? So the basic some steps are there. So I will explain one by one. The first step is need or aim. So what is the need of your design? So that should be useful to society. So first, that's why first you clearly define your problem. So what is your problem? So means suppose you want to design a scooter. So what are the basic requirements? The fuel consumption, what is the power speed and overall dimensions of the vehicle, and what is the engine speed. Clear. So what is the piston diameter? All these things are basic requirements. So before designing, have to define your problem very clearly. So you have to design a 4-stroke engine, 4-stroke petrol engine with 80 km per liter speed, 80 km per liter fuel consumption, and the 80 kmph for kmph, the speed of the vehicle. So overall dimensions are 300 by 200. So like that, you have to define. So some requirements we have to specify. So that is for what purpose? What is the basic need of design? To carry the passengers from one place to another place. So like that, the application of your product that should be useful. Clear? Before identification of your problem, the important thing is how to survey some feedback, some requirements from the customers. Clear? So that is called as a market survey. After market completion of market survey, so identify the common requirements and define a problem. So that is our need. Next one is synthesis. So synthesis means so identify the possible mechanisms. So what are the mechanisms required for our product? Is there any rotational mechanism? Is there any reciprocating mechanism? So what is the mechanism required from rotary motion to converting rotary motion to reciprocating motion? So is there any slider crank mechanism like that? Identify which mechanism is suitable for our product. Clear? Our design. So identify our mechanisms and that is fix our one of the mechanism for our particular application. So clear? So that process is called synthesis. After that, after identification of our mechanism for our product, analysis of the forces. So here this step is very important. Analysis of forces we will do in design of the machine elements. Clear? So what are the design of what are the machine elements? I will tell you. So in this analysis of forces, first what are the forces acting on your product or elements? Clear? First identify the forces. So many forces acting on our product. Suppose you want to design a four-stroke petrol engine. So there are the machine consists of several parts like piston, cylinder, crankshaft, and a connecting rod. So take each and every element and what are the forces acting on that? So inertia forces and gas forces and thermal forces. Many forces are acting on this four-stroke petrol engine, piston, or crank, connecting rod, or crankshaft. Clear? So first identify the forces and find out the magnitude of the forces. Clear? So that part is the analysis of the force. So according to these forces, select our material. Clear? See, it depends upon the material selection, depends upon the forces, the force and the magnitude. Clear? So some forces. Some materials withstand higher forces, some materials can't withstand higher forces. So that's why, so before designing, first analyze our forces and then select our material. The material selection is a very important criteria in the machine design. Clear? The selection of material depends upon the properties and the composition of the materials, and it depends upon application also. Clear? So I will tell you clearly in later sessions. Next one is design of elements. So this is the design of the machine elements. Now, in this, after the completion, after identification of material selection, and then the design of element. The elements are the machine elements are like the shafts and the bearings and couplings and the clutches, like that. Many elements are there. So now we design design of the individual components of a particular machine. So that parts comes under a design of the elements. And then after that, if after completion of design of elements means so already mechanism identified and the forces also determined, and then the material selection also over, and then find out the dimensions of the element, find out the elements. Clear? And if any the changes are required, so immediately modify. Clear? Modify, and again you can change ever the materials. Clear? And then detailed drawing. So detailed drawing, so prepare the drawing for each and every element of your machine, and then finally goes to production. So this is the design procedure in a machine design. Clear? So this is step by step procedure. So here After modification means your design of after design of elements, prepare one prototype model and you test it, and then if any modifications required, so immediately go back to the material selection step, and then again change your the material or dimensions of element, and again test on it. Clear? So after that, after finalization of the elements and prepare detailed drawings, and then this the final drawings goes to production, so manufacturing department. Clear? For assembly purpose. So this is the structure. The basic procedure of design of machine elements, the function of elements. Now in this, the function of elements means in machine design, already we have learned some steps, and here the procedure of design of machine elements. The elements, the machine elements in the part of the machine. A machine consists of many the components. Clear? So the some components are the general purpose components, and some components are the special purpose components. The general purpose components are the shafts and the couplings and clutches. Clear? The bearings. These all are nuts and bolts. These all are general purpose elements. The special purpose means the piston and the spindles. These the piston or spindle used for particular application only. That's why it's called special purpose elements. The general purpose elements they generally used in the machine design. The shafts for power transmitting. Clear? So like that, the classification of elements are there two types: general purpose and a special purpose. So the function of element means here before designing, the designer has to know the functions of each and every element. So the designer should have the knowledge, the basic knowledge of elements. Clear? So that's why the designer has to learn the basic the subjects, the thermodynamics, engineering, mechanics, vibrations. Clear? And the physics. Clear? So then only he can apply his skills and imagination final product. Clear? So ultimately the design process, the outcome is to describe the product. Clear? And to perform that designed product should be in economy and very efficiency and also reliably. Clear? So here identify the functional elements, and then analysis of for the same procedure from machine elements also in analysis of forces also, the forces is compulsory, and then material selection. Clear? And then design of the elements, and then same procedure modification and detailed drawing, and finally production. Clear? So here the functional element the designer has to know. Next, what are the requirements of machine elements? Before designing, some requirements are there. So what are they? One is the strength and rigidity. It means that the machine element has to carry the heavy loads, so without fail. So that is comes under strength. So it gives it gives good resistance to the load. And rigidity, it should be rigid. The machine element should be rigid, so that means it should not be bend under the loads. And then weight resistance. So the weight resistance also very important thing in design of machine elements. The abrasive wears and the corrosive wear also there. So the wear resistance, based on this wear resistance, the product life will calculate. Next one is minimum dimensions and weight. So design a machine element should be strength and rigidity and wear resistance, and at the same time the minimum dimensions and weight also important. That's the final shape of the product, and overall dimensions of the product also important thing in a design of machine elements. Clear? So it leads to effect, so it leads to minimize the this cost and the weight also. Next, manufacturability. So it should be the measure of the element should be easy with the fabrication. Clear? So, and the machining. So that is a manufacturability. Whatever selected material that should be manufacturable and the machinable. So then only you can make elements for a particular application. So that's why the manufacturability also important. Clear? And safety. So whatever identified, the shape and the overall dimensions of the element, it should be safety to the operator. Clear? And then conform to standards. So in design of the machine elements, always use the international and the national standards. Clear? And then so many standards are there, and ISO standards and BS standards and ASME standards also there. So I will tell in the next session. And reliability, it should be reliable. So the machine element, so it should be reliable, means it should give the long life. Clear? All these properties, whenever you are the requirements of elements, strength and rigidity, wear resistance, and minimum dimensions, weight, and manufacturability, and safety, and conformance to standards. Whenever you selected or used the standards, national and international standards, that product definitely should be reliable. Clear? So without following the above requirements, you can't say your designed product is reliable. Clear? So that's why the reliability property also very important. And maintainability, the operator easy to maintainable. So maintainability means it can be serviceable and repairable. Okay? And the minimum life cycle cost. The last one is minimum life cycle cost, means it is total cost to be paid by the purchaser for purchasing the element and maintaining cost of the element lifespan. Clear? So that cycle cost is called a minimum life cycle cost. The product, the machine element should be required the minimum life cycle cost. Next one is the engineering materials and their properties. So in the previous slide, in starting slides, I told you the selection of material is a very very important criteria in design of machine elements. So here the material should have some basic properties. Clear? So the selection or proper material for the machine components is one of the most important step in the process of the machine design. Clear? So it which will serve the desired purpose of at a minimum cost. So it leads to minimize the cost also. So that's why the selection of material should careful while doing design. Here, the factors considered while selecting the material. So what are the factors? One is availability, another one is mechanical properties, and cost. So availability means the material should be readily available in market in large enough quantities. Clear? To meet the customer requirements. Clear? So first of all, how to check the availability of material. So after, suppose you have selected one material, so that is available in our market or not. So now first check it. So and then go to your design next steps. Clear? So availability, if not available your selected material, then go for next alternate material. Clear? So without doing any market survey, without doing any analysis, simply you are selected one material for one product, and you have designed and released it into the market. So then definitely the product will not success. So definitely fail. Clear? So that's why before designing, you should concentrate all these points. Clear? Every designer has to follow these steps. Then only your designed product will success in outside market. Clear? So that's why the availability is required. So some parts are available in the market directly. You can use. You can purchase from the market and you can assemble to your design. Clear? So that is some the standard items available. So the bolts and nuts and the springs, right? So no need to design separately. Clear? And some elements are not available in a market. How to machine and how to manufacture. So in our factory. Next, mechanical properties. The most important thing is the mechanical properties. So, what are the mechanical properties? Yes, mechanical properties are their strength, toughness, hardness, creep, clear, and this plasticity, elasticity, clear, so, and rigidity, resilience, stiffness. All these mechanical properties also important. So, while designing or while selecting materials, these factors to remember, clear, and then cost. The material cost also you have to check. So the mechanical properties are strength. So the machine element has to resist the external forces. Clear. So and elasticity and plasticity. So whenever load applied on an element, it's gets deformed. Clear. After removal of load, immediately it goes to original position. So that is called as elasticity property. Already you know, you studied in physics. Clear. And engineering mechanics. And plasticity is do not regain its original shape. That is plasticity. So every material some materials having the elasticity property and plasticity property. First, identify which material having the elasticity, so plasticity properties, and which type of material required for our particular application, your design. Clear? So, and then toughness, ability to absorb energy before fracture takes place. Clear? So, some energy it will absorb. So that type of property is toughness. Clear? Next, malleability, ability to deform a greater extent. Clear? So before the sign of crank. So it is when it is subjected to compressive force, so that it will deform. The ductility is the ability to deform to a greater extent before the sign of crank when subjected to tensile force. So it means whenever applying the tensile force, so it will deform in lengthwise. Clear? The malleability is diameter wise and will increase extend, and ductility is lengthwise will increase. Next, Britainless property. The property of the material which shows negligible plastic deformation. So, without indication of any plastic deformation, the element will fail. So, that type of property is called as the Britainless. So, the fracture takes place. So that means without indication, without any sign of the crank. So, suddenly it will fail. So, example, the cast iron material. Clear? The Britainless property uh, is having the cast iron material, and then hardness, the resistance to penetration or permanent deformation. So the permanent whenever applied load on a particular material, so some it should be a withstand that material, or otherwise do not give any deformation, any do not give any marks and scratches. Clear? So that is so penetration. So the resistance to penetration, that property hardness. Next one is the manufacturing considerations in a design. Some manufacturing considerations also important. The so first one, minimum total number of parts in a product. Clear? So minimum total number of, so you have to reduce your the number of components in our particular design, and then minimum variety of parts. So the variety of parts minimize, and then use standard parts. Clear? And use the modular design, and design parts to be multifunctional. The parts should be multifunctional. So like that you have to design. Clear? And then select least costly material, and then design parts for ease of manufacture, and the shape the parts for minimizing the operations. Clear? So all these things comes under the manufacturing considerations. While manufacturing the product, you have to remember these points. So then definitely your product will success. Clear? So these are the references I have taken. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.